Yeah, the maximum time for recording these videos is 15 minutes. I think I was getting pretty close to it, so I thought I'd better stop and do this as a second video for paper 1, question 27. So we've just done the organic question. Question 27 is clearly involving a titration. An unknown monoprotic acid is titrated with 0.1 mole per liter NaOH. This will be a 1-to-1 ratio if we need it later because the acid is monoprotic and the base is monobasic. Now you'll notice it starts with a pH of 3, so it's telling you basically this is a weak acid. All right, if it was a strong acid, it would be down about 1. Okay, use Le Chatelier's principle to explain why phenolphthalein is a suitable indicator for this titration. Okay, for this one, guys, you would need to go to the data book, and I'm going to it now as I talk to you, and I'm on page 14. And there you will see on page 14, please have your data book. Don't just take my word for it. Look at what I'm doing. You will need to do the same. You need to find an indicator whose range is basically very close to sort of, between about, 8, maybe just under 8 and 10. And if you look at the list, phenolphthalein has a range of 8.3 to 10. So it's perfect for that titration. Before that last drop came in, it was shown its acid color, and after the drop has come in, it's shown its alkaline color, which means it's changed color, which is what you need in a titration. Okay, so there's the equation for any random indicator. It's colorless there, and it's pink there. So when you add the alkali, it's all right, you've got to explain. When you add the alkali, you are removing hydrogen ions. Le Chatelier says that the system will oppose you by shifting to the right to replace them, and by shifting to the right, you're going to see the ion minus ion, which is pink in color. Would the pH of the equivalence point and the volume of NaOH change if the concentration was doubled? Well, the equivalence point wouldn't change at all. You're still using the same acid and alkali. That would make no difference. However, the fact that it's now double its original concentration, okay, let's have a look, double the original concentration, you would now, let's have a look. So instead of using, what was it before? 5 mil, okay, 5 mil was required before. If this was now doubled in concentration, then you would obviously halve that volume to 2.5, so the same number of moles is going to be used. Oh, and that was it. That was just the one question. I might have been able to fit that in. Anyway, it's not a problem. All right, you've got 2 videos, a very short one to finish off, and I will now be moving on to do paper 2.